Okay, for what I hope is the last part of this particular chapter, it's miscellaneous information that will be very important for you to have an exposure to and have a little bit of working knowledge of, certainly as you go forward and help you understand a little bit more about what you have learned already. This kind of repeats what we already talked about with regard to this process of bone remodeling and the fact that homeostasis has to be maintained. Otherwise, you end up with a disorder we tend to label as osteoporosis. And you can see the two different images, and this does not come from your textbook, although your textbook has a pretty good picture of osteoporosis and comparing that to normal bone. But you can see how in osteoporosis the openings are much larger and there isn't as much what do I say texture with regard to the normal bone. What that equates to is the fact that that osteoporotic bone is not going to be strong. And as osteoporosis progresses, then a person can have the type of fractures which we called pathological or spontaneous fractures. With regard to bone degeneration, this can happen very, very quickly, and it does if you've ever broken a bone where you are inactive on that bone. You see that the loss of bone mass happens very quickly. It can then, if you're healthy, it comes back, but it can happen very, very quickly with regard to inactivity. There are certain nutritional factors that, nutritional and hormonal factors that are necessary for normal bone, one of which is calcium, which we've talked about, phosphate, magnesium, fluoride, iron, and manganese. These are all things that are minerals that are needed. Vitamin C is required for collagen. Collagen fibers, remember, make up a good portion of bone. That's the non-living matrix. You also need vitamin A to stimulate osteoblast activity, as well as vitamin C to stimulate the differentiation into osteoblasts. Vitamin D3, remember that gets its start in the skin, goes to the liver, then to the kidney. When it gets to the kidney, then you have the usable portion of vitamin D. So you have cholecalciferol, that's a cholesterol-based steroidal compound. Vitamin K made in the large intestines, vitamin B12 also act as cofactors. Hormones that affect bone health are calcitrol and parathyroid hormone. Calcitrol helps calcium absorption in the digestive tract, and then also growth hormone and the hormone that's released by the thyroid gland, thyroxine, stimulate bone growth. Estrogens and androgens, which are the male and female sex hormones, stimulate osteoblasts, the building. Calcitonin and parathyroid hormone regulate calcium and phosphate levels, and we'll look at that in a minute. This comes from your book. It's a nice breakdown of composition of bone. And you can see that most of bone is calcium. You do have the other minerals, phosphate being the second most common bone, and then the relationship between calcium and organic compounds. So mostly collagen. In terms of calcium regulation, which is a very important concept, certainly when you are looking at nerve conduction, you're looking at heart rate, manufacturing of membranes, calcium regulation in the blood is closely regulated. So calcium ion in fluids, blood and extracellular fluids, and intercellular actually also, by calcitonin and parathyroid hormone, which basically work synchronistically. I guess you might say they oppose each other in controlling storage, absorption, and excretion. They affect how it's stored, how it's absorbed in the digestive tract, and where it's excreted in the kidney. So they're going to affect rates in all those areas. Parathyroid hormone is produced by the parathyroid gland, which is found on the posterior aspect of the thyroid gland. And the thyroid gland is about at your Adam's apple-ish, you know, right on your thyroid cartilage. Calcitonin is secreted by the thyroid, by the C cells in the thyroid, and works to decrease calcium ions, whereas parathyroid hormone works to increase calcium ions. And then let's look at this chart that we have. These charts come from your book. So we're looking to increase blood calcium levels. So increase the level of calcium in blood. This would be a negative feedback that you have baroreceptors in the brain that respond to the hormonal system that look at blood calcium levels. So if they drop below a certain level, 8.5, a message is sent to the parathyroid gland to secrete parathyroid hormone, so PTH. That will cause the bone to start breaking down and releasing stored calcium ions. So those osteoclasts will be stimulated. That will cause the intestine to increase the rate of absorption of calcium, and that will cause the kidneys to retain calcium ions and also release more calcitrol, which then acts on the digestive system and increases its rate of calcium absorption. That will all happen until calcium levels become normal again. Again, negative feedback. Then if you have calcium levels too high on the other side, so this again, negative feedback, impulse to the brain. The brain's going to say, oh, calcium levels are way too high. We need to lower them. What will happen is a message will be sent to the thyroid gland, and the parathyroid parafollicular cells, the C cells in the thyroid gland, will secrete calcitonin. That causes osteoclasts to stop their work, so inhibit them, so that calcium is not broken down. That will slow the rate of absorption in the GI tract, as well as tell the kidneys it's okay to secrete calcium in the urine, as well as don't release any calcitrol. So we don't want to help the intestinal tract absorb. We just want to get rid of some of these calcium ions in the urine, and all of that will happen until calcium levels come back into what is considered a normal range. And that's how parathyroid and the calcitonin from the thyroid gland work together to constantly maintain calcium levels, particularly of the blood, all the time. And this is always, I mean, this is happening all the time. In terms of fractures, a little bit about how fractures heal. A fracture is a break in the bone because you have more stress to the bone than it can handle. 4 basic steps to fracture repair. First, you have a major hematoma that then clots. That hematoma is good because that brings cells to the area, and that clotting can establish a fibrous network to wall off and keep the bleeding under control, so basically clot the blood. And then what happens is you have a callus formed. That callus is cartilaginous based, and this is kind of like your hyaline cartilage or endochondral ossification. It happens somewhat like that, where you have this cartilage based, the chondrocytes then dying off, enlarging, dying off, and then you have osteoblasts coming to the area. The thing that happens is spongy bone is made first, and then spongy bone gets remodeled into compact bone, and that we recognize as the type of bone for bone for a long bone. The thing that happens with regard to this bone is it is remodeled for about a year. So this break in the bone is repaired as quick as possible so that you can have some weight bearing on it. Think of before we actually had crutches, etc. But the actual finished bone does take quite a long time for that for the body to actually finish off a fracture. And then here's some x-rays of some common fractures. If you're planning to go into anything that is what do I say, x-ray or fracture based, you want to make sure you can pick one from the other. I don't tend to ask these questions. Sometimes you get asked these in lab, though, the different types of fractures, and so you want to give those a look, and it's always nice to see x-rays. And then the last thing we need to talk about is just kind of a I've tried not to talk about age-related changes in the body generally, because age-related changes aren't good. You don't get better with age with anything in the body. You do have the capacity to take care of yourself and maintain yourself the best possible. The only thing that really can get much better with age is your attitude, and also your the way your brain functions is always changing, and I guess if your attitude is better, then what you're saying is your brain function is actually better as you age. But that is attitude related. But what happens to the bones as we age? They become thinner and weaker, and this is even in a healthy person. Your bones are going to become thinner or weaker. So that's why it's very important to do this weight-bearing exercise, basically to put more bone down in areas where you have additional stress. Osteopenia can begin, now this is a disease state, between ages of 30 and 40. This would be an accelerated bone loss, so this would be actually bone softening, and then osteoporosis is bone loss. The loss of bone tissue, as I said, is a normal part of aging, but it's not to the rate where you actually have these spontaneous fractures unless you do have osteoporosis. For example, women can lose 8%, men 3%. Those spongy bones are going to be affected first because of the nature of their design, and this can limit your height. This is where you have these people who actually lose height even in inches, and also tooth loss, which is an interesting thing. Exercise, 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 exercise. What can I say? And then osteoporosis. Again, I try not to focus too much on disease processes in this class. We're mostly learning about normal anatomy, or I guess a normal range in anatomy. So if something is not within this normal range, then it's a disease process or on one or the other. But in order to understand disease process, you have to have a context, and the normal anatomy gives you the context for that. I will see you in chapter 7, which will start talking about the axial skeletal system. Chapter 8's the appendicular, and then we have joints to talk about in chapter 9. See you soon. Bye.